My names are Edward Njogu Karongo, a graduate in Bachelor's in Geomatic Engineering and Geospatial Information System. Today on 21st August 2019, I'm recording a video on my final year project presentation, which was use of big data analytics in managing and use of big data analytics technology in design of a reporting system in KPLC. Stick with me to the end of the recording and get educated. So this is my final year project presentation. The problem statement was the reason that I focused on use of big data is because World Forum Geospatial in 2017, the theme of the day was use geospatial data and deep learning in shaping us to a smarter world. So big data exploration, analytics, and visualization help us drive meaningful insights in in a smarter world. So the reason why I'm using trying to use big data analytics technology is big data. One thing is use of large volume, velocity, and variety. It has been known for better or worse that 90% of the data generated in the last 2 years is more than all the data existing in this world. Then data is normally in two forms, structured and unstructured data. Unstructured data makes 88% of the whole data in this world. In geospatial engineering, we normally use the structured data, which is maybe from surveys, referenced images, TIFF, PEG, GeoJSONs, PNG, all those imageries that we normally use in AutoCAD, ArcGIS, that is structured data. But we ever fail to realize the importance or the meaningful insight or based on geographical geospatial data that we would always bring if we used 88% of the unstructured data. 88% of the unstructured data, like in satellite is always producing data of large volume. Velocity is data that is streaming. A satellite is always picking data that is streaming because it is moving from one side to another side, and it's always in the air picking data for as long as for the centuries it has been. Then variety. A satellite picks data that is, it picks images, temperatures, volume, sound, imageries on vegetation, so many things. So my focus was on social media data, which has a variety of geospatial data. Social media data that has a location aspect becomes by default big data that has yeah. So my problem statement in KPLC today has a manual reporting system where people work text which jeopardizes the restoration efforts in solving of a power blackout. Once you text star 9554, 9 star 551, they normally give you a reference number which is just an automated responder. Basically, the system is not yet automated. So I really looked at generating a reporting system which would play a critical role in power resolution or solving a power outage. So what I focused was use of big data technology. If a customer, if a customer in Kenya Power has a problem and they happen to just use by use of their tweet, they tweet. KPLC should be able to mine that data and get back to them. The insight was once a normal man meets that they don't have electricity in their home, the best thing is for them to tweet instead of maybe texting KPLC or calling customer care who never gets back to you. But this my way of approach or in solving a power outage is that even a billion people can all of them can tweet. Then in a map we'll be able to see how, what they are doing, and through that we'll be able to get an insight of maybe what to do on how to resolve. So my first objective was to mine big data from Twitter on social media outages, then to automate a data cleaning. The second objective was to automate data cleaning process by geocoding. Third one was to automate mapping out processes of power outage incidents. Then the other one was to visualize the results of data mined on web application. My scope of study, I tried to look at Nairobi. This is an imagery of Nairobi County. The other thing was my data and data sources were people's comment, views, personal opinions via Twitter, reference data from radio, rational database. Second data was a Twitter REST API, Leaflet API. This is a JavaScript interactive API that is able to demonstrate things in a map. OpenStreetMap, which has no minting engine, that one I used to geocode. TAF.js was to show demarcation of boundaries, which is a geospatial analysis tool that is able to show different capabilities of some geospatial activities that can be carried. BPM flowable engine. This was used in case management, FDB query checks, and KPLC georeferenced meter number data. Kenya Power has used billions of cash to map out meter numbers in last mile project. So after them mapping out, it means they georeferenced the meter numbers. So this was the way my platform looks. It has a dashboard, incidents, and a task list. This is the way. These are once a customer in Kenya Power reports a power outage. The system creates a case, then this is the task in the task list. This is a task list that the administrator or different people in the system should use. So this is the way to tweet. We are using hash kplc hakuna stima in Lamu, then hash kplc hakuna stima, then hash allocation, or use hash kplc meter number in the complaint. Like example here is kplc one, the meter number, transformer is burning, then you maybe geotag. This is the dashboard that we have the live streams. Once we will be able to tweet, the system will be able to see what is happening. So I'd say that let us refresh the browser. The time as per now is 8:40 Wednesday, 21st, 2019. We are in Juja. So this is Twitter. Twitter, we really want customers from Kenya Power, or customers from anywhere to tweet. They are complaining about power outage. The system mines data, and we're able to map it out. So first, let us log in into the system. The first user is Karongo Analytica. Karongo Analytica is the administrator of the system. Administrator of the system is the person in Kenya Power who is in charge of the boss in the support team. This is the way the interface looks like. So we have a dashboard. Dashboard is just a graph. Then we have incident map. Then we have the task list. The task list and the logout. We'll head into Twitter. Then we need us to tweet something and confirm that the system really minds that. Somebody, we said you come tweet hash kplc, make your complaint. No power, no power because of rain. Then you tweet your location. Your location is will at the moment we will use Thika, hash Thika. We tweet. Once we tweet, we'll confirm that the tweet is into a system. We can see 3 seconds ago. So this is the tweet, hash kplc, hash Thika. So we'll come and confirm whether the system has mined that data. From the system logs, let us see the incidents. These it says the description is Edward checks Howell. and the OpenStreetMap, it has geocoded, and now it is in Thika. We come live from the and confirm that the system is in the incident map, that case is appearing. Let us zoom in. Let us zoom in. We complained about Thika and said hakuna stima. Let us look what we have. Okay, this one was an earlier one. Hash KPLC. You put a meter number, then stima is lost, and they'll be able to get back to you. Let us look at another one. Hash KPLC, no power because of rain. Hash Thika. That is the last thing that we tweeted. We need to what we'll need I will pause so that I may populate the database, and we said the customer from his location should complain, then Kenya Power picks the system and is able to mine data. So let us go here. We want to go back into Twitter. When we go back into Twitter, we need to populate the database so that we may case manage, so that we may case manage, so that we may case manage. So let us look at locations like locations. We have this is now in the system. We can see we have like 10 system. I need we populate the data using Garissa, and these maybe parts of Kisumu. Let us populate the database using Garissa hash hash KPLC power, power surge power surge. It is in Garissa. Let us tweet. Let us look another part of the part of Kenya that we will populate. Another part that we will populate. Let us confirm that for Garissa, the system has really mined the data and recorded it. This let us confirm from the dashboard whether it populated it. Then we can be able to remove this overlay. This overlay I used TAF.js, JS. TAF.js is a capability by a geospatial analysis tool that you're able to show demarcation of boundaries. What these ones happens is anytime an administrator in Kenya Power is assigning or case managing a task, they can be able to know the extent. Like now in this case, once we zoom in this situation, we can be able to realize we can be able to know which location, which business district does an outage where has the outage really happened. Like now here we can be able to tell among these three drops, these three customers complaining, two are in Nairobi County, two are not in Nairobi County. That is why we used this overlay which was taking the GeoJSON of Kenya. Then we intersect and it shows the demarcation boundaries. Demarcation boundaries, basically Kenya Power, when they are implementing these, they should really pick on the business districts. Business districts means where there is a substation. Where there is a substation, we can have the area covered by a substation once, so that in case there is a power blackout from the substation, we can be able to delegate laborers to go work on certain tasks or be able to carry different